Hello, my name is Larasati Palupi from Industrial Engineering 11 Maret University. On this occasion, I will present the results of my research about Husks and Baggase as composite materials characterized by heat resistance. With the first author is me, Larasati Palupi, second author is Mrs. Susi Susmartini, and the third author is Mr. R. Haristianto. In this presentation, we will explain about introduction, method, result discussion, and conclusion. Indonesia is known as a maritime country which has a water area larger than its land area. Therefore, Indonesia has abundant marine resources, one of which is fisheries resources. Fish has nutritional value and high source of protein. According to Sondana in 2013, the high protein value in the fish make the fish quickly decay 6 to 7 hours after catching. According to Sofian in 1983, there are three ways to maintain the freshness of fish, namely by using ice, with cold air or refrigeration, and with cold water or chiller. Low temperature storage of fishery products aims to inhibit or stop substances and microorganisms that can cause spoilage or degradation of quality and damage. A common technique used in cooling fish is to use ice cubes in a cooler. According to Rizal in 2019, one type of cooler that is often used is styrofoam. The physical, chemical, biological properties of the styrofoam synthetic material are not easily degraded or non-degradable by soil microorganisms, so that when the material is no longer used, it will have implication for the disappearance of life in the soil, water, and environment, so that it can interfere with environmental health. According to Biswas in 2001, the development and use of natural fiber reinforces composite materials can make products with good acoustic and thermal characteristics, use low energy, are environmentally friendly because of their biodegradable nature, so that they can be decomposed easily and safely, as well as for sustainable use. Types of natural fibers that have the potential to be used as composites are baggase and rices. Because both materials contain silica, can be used for composite materials with heat-resistant characteristics, which are durable and strong. The independent variable in this experiment are composition with level 50% of rices with 50% of baggase, 40% of rices with 60% of baggase, 30% of rices and 70% of baggase, and particle size mass 10, mass 20, and mass 30. The dependent variables is heat resistant value of the composites. The hypotheses in this experiment are the composition factors, particle size factors, and the interaction between compositions and particle size factors do not affect the value of heat resistance. This is the result of thermal conductivity test. Results from thermal conductivity test in watts per meter of Celsius degrees. The highest heat resistance value is 7 treatment, which is composite that made from 30% of rices and 70% of baggase, with particle size mass 10. Composition with 50% of rices and 50% of baggase get an average value of 19.8 Celsius degree per watt. For composition with 40% of rices and 60% of baggase get an average value of 19.66 Celsius degree per watt. And composition with 30% of rices and 70% of baggase get an average value of 20.9 Celsius degree per watt. Particle size mass 10 get an average value of 19.85 Celsius degree per watt. Particle size mass 20 get an average value of 19.62 Celsius degree per watt, and particle size mass 30 get an average value of 19.36 Celsius degree per watt. The heat resistance value that have been counted is the carried out ANOVA testing, which is used to find out which factors affect the value of heat resistance. According to the ANOVA test, composition factors and particle size factors affected the heat resistance value, but the interaction between composition factors and particle size factors did not affect the heat resistance value. Based on the result of the ANOVA test, the SNK testing is carried out on composition factors and particle size factors to find out at which level has the most significant effect on the value of the heat resistance. The SNK test shows that composition factors of 30% rices and 70% baggase has a higher value among the other levels of the factor. According to Wibowo in 2008, it can be happen because baggase has higher silica of 62.78%. According to MyWita in 2014, composites with more baggase composition have a lower heat conductivity value, where the lower the conductivity value, the higher the value of the heat resistance. The SN shows that particle size mass 10 has the higher values among the other levels of the factor. According to Mujtahid in 2010, that the heat resistance value is affected by the number of cavities in the composites. Composites with large sizes of palm powder have more cavities compared to composites with smaller size of palm powder. Thus, if one the highest average value of heat resistance can choose the mass particle size factor 10. The conclusion of the experiment is composition factors and particle size factors was affected the value of heat resistance. The interaction between composition factor and particle size factor did not affect the value of heat resistance. Since the composition factors and particle size factor affect the value of heat resistance, the SNK shows that composition of 30% stress test and 70% of baggase and particle size mass 10 is the best choice to make a composite that have a high heat resistance value. The highest heat resistance value is 20.32 Celsius degree per watt, which made from 30% of rices and 70% of baggase with particle size mass 10. I think it's enough for me. Thank you for your attention.